Here we have the lesson, the second lesson on factoring, this time difference of squares. This binomial factors in 5 seconds if you spot this pattern, a squared minus b squared equals a minus b times a plus b. It's just that easy. We're going to keep this formula so that we can work on some examples. A difference of squares is one perfect square minus another. So we need to look for perfect squares like 1, 4, 9, 16, 25, and even exponents on variables. Important, if you see something like this, a squared plus b squared, which is a sum of squares, that doesn't factor over the real numbers. So don't force it. This doesn't exist for factoring. Let's see this first example. We have the expression x squared minus 9. So the first thing that we need to do is look for a and b. So we can basically assume in this case we have that a squared is x squared while b squared is 9. So we can say that, let's say a squared equals x squared and b squared equals 9, so that we can easily find the values of a and b. For finding a, it's just as easy as just taking the square root on both sides of this equation. We can cancel out the index of the root with the exponent, like that, and we are gonna get that a is equals to x. Then for b, what we can do is exactly the same. We're gonna take the square root on both sides. A square root of b squared will be just b, and square root of 9 is 3, because 3 squared is 9. So b will be equals to 3. And with these two numbers already, we can just go and use the formula. So a squared minus b squared equals a minus b times a plus b. We know here a is x, so x minus b, which is 3, so minus 3 times x plus 3. And we are done. Let's see another one. This one has a coefficient for the square of the x. We do have 4x squared minus 25. And we're going to do exactly the same thing that we did before. We're going to find the square roots for each of these terms so that we can see what is the value of a and what is the value of b. So we already know if we take the square root of the first term, square root in this case of 4x squared, we're going to get a. And if we take the square root of the second term, which in this case is 25, then we can get b, right? So what is the square root of 4? The square root of 4 is 2. 2 squared is 4. And what is the square root of x squared? It's just as easy as we can just cancel the exponent with the index of the root. So we get 2x. So this is our a, and the square root of b is just 5. There we have our a and our b, and by using the formula we can say that 4x squared minus 25 is equals to 2x minus 5 times 2x plus 5. If you want to check your result, you can just distribute again this expression and see if you're coming back to the original binomial. So let's see it. 2x times 2x, that's gonna be 4x squared. Then 2x times positive 5 will be 10x. Negative 5 times positive 2x will be negative 10x. And negative 5 times positive 5 would be negative 25. Positive 10x minus 10x, that's just 0. We can cancel them and we get 4x squared minus 25, which is the same expression that we had at the beginning. Let's see this other example where we have coefficients on both terms. We have 9x squared minus 16y squared. As you can see, we have both. We have variables, two different variables and two different coefficients. So exactly the same that we did before with the other two exercises. We are going to find a by taking the square root of the first term, which is 9x squared. So a equals the square root of 9x squared. Then b is the square root of the second term, which is in this case 16y squared. So the square root of 9 is 3. And the square root of x squared is just by canceling the index of the root with the exponent, and we get x. 3x will be our a. And for b, the square root of 16 is 2, and then the square root of y squared is just y, by doing the same. So now we can then say 9x squared minus 16y squared is equals to 3x, which is a, minus 4y, which is b, times 3x plus 4y. And we are done. Finally, let's see this example which involves a fraction, a kind of fraction of the first term. It's x squared over 9 minus 25. So exactly by doing the same thing, taking square roots, we are going to find a and b. So a would be the square root of x squared over 9. Now, as you may know, by properties of the roots, we can distribute this square root between the top and the bottom of this fraction, so that we get square root of x squared over square root of 9. So the square root of x squared is x over the square root of 9, which is just 3. And that's our value for a. And for b, we can take the square root of 25, and the square root of 25 we already have seen it's 5. And that's it. So if we build the factored form of this expression, it must be a minus b. So x over 3 minus 5 times a plus b, which is x over 3 plus 5. And we have finished. Here you have 2 practice exercises so you can check your understanding. And obviously here you have the answers so you can check your results. So if you ever see a squared minus b squared, instantly write a minus b times a plus b. So this way, an expression like 4x squared minus 25 will become instantly 2x plus 5 times 2x minus 5.